Okay, so we're going to finish up this finding limits algebraically lesson. So you're going to need the 2 sheets that we started on yesterday or Tuesday. So we're going to go to number 5. So number 5 says to evaluate the limit using direct substitution if possible. So when we plug 0 in for x in the numerator, tangent of 0 is 0. And then obviously when we put 0 in for x in the denominator, we get 0. So 0 over 0 is indeterminate form. So we are going to need to do something. So number 6 tells you what to do. So it asks you to rewrite the function using only sine and cosine. So you may or may not remember those identities from last year. So if you don't remember them, don't freak out. They're in the front of your textbook. And a way to write tangent using sine and cosine is to write it as sine over cosine. All right. And then what we would want to do is rewrite it, because that's kind of messy. We have a fraction inside of a fraction, so that's going to simplify down to sine of x over x cosine of x. All right, so that doesn't really look much better. So what we can do now, it tells you to do, is write it as a product of 2 fractions. Now, yesterday we talked about these memorized forms where we have this sine of x over x, and we can use it to find the limit as x approaches 0. So that's a special limit that we're going to use quite a bit. So when I write it as the product of 2 fractions, that is definitely going to be one of my fractions, sine of x over x. And you have to think about what you would multiply that by to get this, and that's going to be 1 over cosine of x. Okay. And then 8 asks you to use your knowledge about limits to evaluate the limit as x approaches 0. Now, you don't have this knowledge yet, but we're about to talk about the properties. If we have the limit of a product, we can rewrite it as the product of limits. So we could break it apart as the limit as x approaches 0 of sine of x over x times the limit as x approaches 0 of 1 over cosine of x. Okay, and then if we look back at that graph of the sine of x over x, and we're approaching 0 from the left and the right, the graph, even though there's a hole at the point 0, 1, the limit as x approaches 0 is going to be 1. So this whole limit is equal to 1. And then for the second one, we can do direct substitution. We'll take 0 and we'll plug it in for x. All right, so hopefully you guys remember that cosine of 0 is 1. So this is going to end up being 1 times 1, which obviously is 1. All right, so let's look at the other page. And we're going to finish in this important ideas box. So another thing you can do to evaluate limits is to use the limit properties to simplify. All right, so the first one is if you have the limit as x approaches anything of a constant, that's just going to be whatever that constant is. The second property also uses a constant, but this time the constant is being multiplied by a function. So what we do a lot of times is just multiply by that constant on the outside of the limit. All right, you could probably figure out 3 through 6 on your own. So for sums, differences, products, and quotients, if you have that going on inside the limit, you can separate it into multiple limits, which is what we're going to do. There's a fly buzzing around my head. Okay, so on this last one, number 6, we just need to make sure the limit as x approaches a of g of x is at 0. Because if it is, then that limit would not exist. All right, and then this last one is a composition. It's slightly different. It's going to be f of the limit as x approaches a of g of x. All right, so let's skip down to where we left off, and that's with g. And g is very similar to the one we just did on the other sheet. So when I put 0 in, sine of 0 is 0, and then 0 times -1 is 0. So we do end up with 0 over 0. So that tells us we need to do something, because there is going to be a limit, but we need to do something algebraic to figure it out. And so what we're going to do is break apart this into 2 fractions. So the limit as x approaches 0 of sine of x over x needs to be 1 over our fraction. And the other one is going to be 1 over 2x minus 1. All right, and then what we can do now is break it. We can use a property that we have the limit of a product. We can break it apart into the product of 2 limits. Oops. Okay. And then we know, hopefully it's going to get ingrained in your head, that the limit as x approaches 0 of sine of x over x is 1. And this other limit, we're actually going to do direct substitution, plug 0 in for x. All right, so we end up with 1 here, and then that's going to be -1. So that limit should equal -1 when I multiply. All right. For h looks a lot like sine of x over x, but there's a little bit of some issues. So I want you to write some limits down on the front of this sheet, because there's some room at the top. I don't have a lot of room on the back side. So what I want you guys to write, a limit to remember, is the limit as x approaches 0 of sine of x over x. That is going to be 1. But this rule also works whenever x has a coefficient. So the limit as x approaches 0 of sine of, we'll call it kx over kx, as long as those coefficients match, that's also going to be 1. All right, and then there's another one that's a little harder to remember. We don't use it quite as much, but it's the limit as x approaches 0 of 1 minus cosine of x over x. And that limit is going to be 0. So I know there's a couple on your assignment that you have to use that one, so don't forget about that one. All right, so let's go back to h. So we have a 3x here. So I need my denominator to also have a 3x to be able to use that rule. So I'm going to multiply my denominator by 3. So I have a 3x down there. However, it's not legal mathematically to do that. So I would also need to multiply the numerator by 3. So that will change the value. No, it won't change the value. It will change the way it looks, but the value will stay the same. So let me write down what I would get. Hold on. So it's the limit of 3 sine of 3x over 3x. Sorry, I drew my fraction bar a little too big. And I didn't do the x approaches 0. Okay, let's try this again. It's the limit as x approaches 0 of 3 sine of 3x over 3x. Now this 3 that's in the numerator, I don't really want. So I'm going to multiply by it on the outside. It's using that second property. So that second property tells you that if you have a function multiplied by a constant, you can multiply by that constant on the outside. So that's what we're doing. All right, so that's 3 times. And then this limit as x approaches 0, sine of 3x over 3x is just 1. So we end up with 3 when we do 3 times 1. Okay, let's look at example 2. Example 2 is using pretty much all the properties. So we know that the limit as x approaches 2 of h of x is 5. The limit as x approaches 2 of g of x is 0. And we're going to find some other limits. So for the a, we have the limit of a sum. So we'll change it to the sum of limits. Now, on the free response questions that involve using these properties, you get a point for writing what I just wrote. So I know it's kind of annoying writing a whole bunch of things in calculus, but you do not want to miss out on those points. So you need to show them what property you're using and then actually use it. So in the place of the limit as x approaches 2 g of x, we're going to put in 0. The limit as x approaches 2 of h of x, we're going to put in 5. And so obviously when we add those together, we get 5. All right, for this next one, it's going to be the limit of a product. So we'll change it to the product of limits. All right, I hope you guys can't hear that stupid fly buzzing around. All right, so then I'll fill in 0 and 5. So when I multiply those together, I'm going to get 0. All right. I did these out of order, so it's okay. On B, we have the limit as x approaches 2 of 3 times h of x. So we're just going to bump that 3 on the outside. And then in the place of that, we're going to put in what it equals, which is 5. And we'll get 15. All right, you guys try D on your own. All right, so this one, we go ahead and divide it up. And so we get 5 divided by 0. So because you're dividing by 0, that this limit does not exist. Okay. For example 3, this one involves a composition. So we used compositions last year. This is the limit as x approaches 1 and g of f of x. So it's a little different than the other properties, but whatever is outside goes outside, and then it's the limit as x approaches 1 of f of x. Right, to find the limit as x approaches 1 of f of x, we're going to take 1 and plug it into x. So I'll change colors. Just take this one and plug it right there. So that's going to be 5 minus 1, which is going to be 4. And then to find, we don't have limits anymore. We're just evaluating g at 4. So we'll plug that in. And we should get 64. So that's how you do the limit of a composition. All right, and then this last one is a piecewise function. And piecewise function, we have everything on the left side of 1. We're going to use 12 minus 2x for that graph. So 1's right here. So over on this side, we have something like that. It's not exact, obviously. And then on the right of 1, we use x squared minus 3 over 5. So it's some parabola on this side. So on A, we want the limit as x approaches 1 from the left. So if we're coming from the left, we're using this one right here, coming towards 1 from the left. So this is the first piece. So we would plug 1 into the first piece. And we're going to get 10. All right, and then for the second one, we want to come towards 1 from the right side, so we're using the second piece when we're coming from the right. So we'll just plug 1 in, and we get negative 2/5. All right, and C is asking us to find the limit as x approaches 1 from both sides, and you can tell that they don't touch each other. This top one is up at 10, and this bottom one's supposed to be down at negative 2/5. So what do you guys think that means about that limit as x approaches 1 of f of x? I hope you thought that it does not exist. And when a limit doesn't exist, it is a good idea to explain why. So this limit does not exist because the limit as x approaches 1 from the left of f of x does not equal the limit as x approaches 1 from the right of f of x. All right, so I'm going to give you guys your assignment. It's on Google Classroom, so you may already know it. Some of these are kind of tough, so sometime when I have a minute, the ones I think that you might struggle on, I'm going to just record myself working them out, and as you're going, if you just really cannot figure it out, then you can look that up. So good luck, guys. I'll see you soon.